Good afternoon, students. Today we're going to have new topic, and that new topic will be about trigonometry. As you know, I wanted you beforehand to have this topic, especially I told Fazal Khan about this. And actually we planned to explain this topic for a month. This topic a little bit hard, that's why we thought it must be interactive. Okay? While I ask some questions, you must answer, okay, during the lesson. And let's start first the name of topic. First, the chapter is called Trigonometry. And topic, just basic concepts and formulae. So, prior to starting, I want to check your knowledge about this topic because in geometry also we've started, if you remember. In geometry, we started right triangle trigonometry, yeah? And you know how to define sine, cosine, tangent, cotangent, yeah? And okay, first of all, let's define the word trigonometry, etymology of trigonometry. What is trigonometry and how is interpreted in English language? Because trigonometry is not in English language. It came from the other language to English. How can you define?
Trigo is like three, and not trio is trigonometry is triangle, right?
Yeah, solving of triangle or measuring triangle, yeah? Trigono, it's actually three angles, and metrio, this is measurement. Trigonometry, measurement of triangle, or solving and a triangle. Okay, solving a triangle. Trigonometry means solving or measurement of a triangle. Okay, this is the first one of today's lesson. This is actually definition or translation of the word trigonometry. Am I right, genius? Yeah? Okay, so first of all, we'll start basic concepts and formulae. How is trigonometry explained in algebra, not in geometry? In algebra, it's a little bit different, but what we learn in geometry might be partly the same, but not fully. Partly the same. Okay? What does it mean? Partly the same. In geometry, we define it by using right triangle trigonometry. The opposite side over hypotenuse, this is sine. Yeah? It's also a little bit used, but in algebra, we use actually the axis, OY and OX. We use coordinates. We use the axis in algebra. Okay? For example, as you know, Cartesian coordinate system consists of two axes, x-axis and y-axis. Let's draw this. OY and OX, abscissa and ordinate. We drew this, yeah, to the whiteboard. And in algebra, the definition is given like this. Y is sine, x is cosine. Y is sine, x is cosine. Okay. It's actually a definition of sine and cosine. How about tangent and cotangent? Yeah? How are they defined?
the division of two
Cosine with sine.
cosine to sine and sine to cosine.
Yeah.
Tangent, it's sine divided
By finding division of them. Yeah, tangent is sine over cosine. Cotangent is
opposite of
cosine over sine. Okay, y is sine, x is cosine. We understood this. Axes are called like sine and cosine. But to find values of sine and cosine in degrees, we must use unit circle. Unit circle means a radius is 1 in this circle. Okay, let's draw this circle. And center must be 0, 0. Origin must be center of unit circle. Why do we need unit circle? Because by finding values of sine and cosine, we need this circle. Okay? So 1, 1, minus 1, minus 1. This is unit circle. Why unit circle? Because radius is 1. If radius is 1, such kind of circles are unit circles. Okay? And can you define geometrically what is circle and what degree actually circle expresses?
360.
360. And how is it called in math dictionary?
One circle.
No. Complete turn. Yeah, complete turn, we can say like this. And or revolution. Did we talk about that? One revolution or one complete turn. It's 360. It's circle. And the circle is 360. Why do we need this? Because while finding values of sine, cosine, we use some degrees. For example, sine 60, sine 90, sine 200, yeah? We use degrees. Okay, we're going to give degrees of circle, and it's 360. But the point, start point, it's called P, and 1 and 0, yeah? This is 1 and 0. This is start point. But first of all, my start point is actually 0. I'm not changing my position. I'm standing, let's say. Yeah, I'm standing. I'm not changing my position. But if I change fully my position, if I turn around 1 times fully, again I'll be at my position. Yeah, I'll be in my position. I'll be standing again. Yeah, if I just turn fully. And anyway, position doesn't change. I'll be again standing, looking at the straight side, yeah? And that's why starting point and 360, it's the same thing, yeah?
Yes.
For example, sometimes we say, this person changed it to 180 degrees, yeah? You change it 180%, yeah, we say. In this case, 180 no full, yeah? It was start point, and he came here. Now he's not the same person as he was in the past, okay? If he changes into 360, complete turn, in this case, that person is the same. It's actually trigonometry, and we talk now this. Starting and beginning point, starting or beginning point or end point, this is 0 degree or 360. You know, actually axes are perpendicular to each other, am I right? They are perpendicular to each other, and this degree is 90 degrees. 90 degrees. In this case, this point is this point is 0 and 1, and this is 90 degrees, yeah? If 1 quarter is 90 degrees, second quarter also 90 degrees. And 2 quarter is going to be
180.
180. It's going to be minus 1 and 0, yeah? And the third one, again 90, we're going to add 270 degrees and 0 and minus 1. These are 4 points. These are 4 points. Okay, these are 4 points and these are 4 degrees. So, why are they necessary? Why are they necessary? So, what do you think about this?
They will be used while schooling.
Yeah, they will be used to find values of sine and cosine. Am I right, Hudayberde? Firdaus? Do you have any idea about this? Do you have any idea about this?
No.
What kind of idea do you have? You don't have? Okay. So 0 degree or 360 degrees. Sine 0 or sine 360. Values are the same here. Because the point is the same, that's why value is also the same. But what is sine? Sine is y. Y here?
0.
0. 0. 0. Yeah? And cosine?
1.
Cosine actually x-axis and x here 1. As Timur said, it's 1. 1, 1. And what about this degree? 90 degrees, yeah? Sine 90 degrees, it's gonna be 1. And cosine 90 degrees, 0. And the next point, sine 180 degrees, it's gonna be 0. Cosine 180 degrees, minus 1. And sine 270 degrees, it's gonna be minus 1. Cosine 270 degrees, 0. So that's it.
Then sine is y and cosine is x, yes?
Yeah. But what about tangent and cotangent?
Tangent it's sine or cosine, and it will be like tangent 0 degree. It will be 1 over 1 over 0, and it will be
Okay, let's see. Look, students.
There are some exceptions where we don't have tangent and cotangent, because there are these places where we should divide by 0, but we cannot divide by 0.
You're right. We have such cases. But to define this one, let's put such kind of line, which is y equals x. Yeah? Y equals x. This is just linear function. Y equals x. Am I right, Firdaus? Okay, please pay attention to the lesson. Okay. And now we have this line. Yeah? And at this point, intersection point, actually x, it's sine, x is cosine, y is sine. Yeah? And this one height is y, x is cosine. Yeah? Am I right? X cosine, y is sine. Let's find this coefficient of angle. Coefficient of angle. What was that actually, coefficient of angle?
slope.
Slope. What is slope in linear function? K. And linear function, if you remember, it was y equals kx plus b. Yeah? K here, angle of coefficient of angle. Yeah. Okay. What is k here?
1.
K is 1. In this case, if it's y0, it's x0. And according to geometrical interpretation of tangent, the opposite leg over the adjacent leg. Yeah? Tangent alpha, it's the opposite leg over the adjacent leg. And opposite leg here, y0. And adjacent leg, it's x0. Yeah? And
y0 it's sine.
sine, it's cosine. And we said k is here 1. But look, if y equals k, and if it was 90 degrees, in this case it's going to be isosceles triangle.
Yes.
If right triangle isosceles, one angle is 90, the other angles is?
45.
The other angles are 45. 45, 45. Am I right? Isosceles right triangle, 45, 45, because one angle is 90. In this case, we can understand if alpha is 45, yeah? In this case, tan 45 is 1. We found the value of tangent. Now, yes? We found the value of tangent. What is the translation of tangent to Russian?
Tangent. From Russian.
Okay. So, thanks. Okay. It's actually line. Tangent, it's line. It shows, actually, there is always slope, and this kind of slope is called tangent. You said in the beginning it's slope. So it's slope. It doesn't change. Tan 45 is 1. In this case, we can say sine alpha over cosine alpha is 1. In this case, sine equals cosine. Values of them also equal. In this angle.
At the point of 45 degrees.
Yeah. And what is the value? It was your home assignment.
From the square root
Square root 2 over 2.
Square root of 2 over 2. Square root of 2 over 2. That's it. If they are equal, in this case, division also will be 1. Okay? So, did you understand how to define tangent?
Yes.
Definition?
Why is there tangent and sinus alpha over cosinus alpha is equal to 1?
What is the coefficient of this line?
1.
And k is actually slope of linear function. Slope is tangent alpha. Tan alpha in this case 1. We talked at this when we learned linear function. K equals tan alpha. If k is 1, tan alpha is 1. In this case, that's it.
Then tangent of tangent is equal to k?
Yeah?
Yes.
Always.
Yeah.
Tangent slope k.
In linear function, k always equals tan alpha and it's called slope. Yes, Firdaus? Am I right? Do you think so? Okay, thanks. So, now cotangent, actually, cot alpha, it's cosine alpha over sine alpha. Yeah? It was the second one, and it's the third one. So, now I have to provide you with the signs of sine, cosine, and tangent, cotangent. Signs.
We will use planes here.
Yes, planes. Yeah, planes. I'm drawing planes actually, you're right.
Like positive and negative.
Yeah, sine actually y, yeah. Sine is y. Okay, let's see first sine alpha. Yeah. Let's see the signs of y. What is the signs of y in the first and in the second planes?
In the first is plus, in the second is minus. Plus minus. Yes.
That's it. And here cosine alpha.
Negative.
In the first,
Positive.
Plus negative.
Minus plus.
so did you understand how to find?
Yes.
Sine is y-axis. In this case, we're going to look at the sines of y. Yeah. And cosine is x-axis. We must look at the sines of x-axis. But tangent and cotangent, actually, division of them, yeah?
Yes.
Division, you know how to divide negative number to a positive number to negative number, yeah? Sorry? Which part you didn't understand? Sorry? Sines of sine alpha cosine. Look, sine actually this axis, y-axis. And what is the sine of this y at this point? Sine это что? Знаешь это что? Нума? Okay. So, what is the sine of y here?
Always positive.
What is the sine here?
1. From 1 up to plus infinity.
What kind of numbers actually are here?
Positive.
Positive, that's why positive. Below, they're negative. Cosine. Now we are looking at x-axis. Here it's positive, negative, negative, positive. And tan alpha is division. Sine alpha over cosine alpha. Plus over plus. Plus. A plus over negative. Negative. Negative over negative.
Positive.
And again negative over. That's it. And cotangent also the same. Because it's also division. That's it. Did you understand now how to find the sines of this one? Abror? No problem? Okay.
I'm looking to sleep. Can I push cold water?
Okay. Yes. So, now we'll see the formula of radian and angle. How to actually change from radian to angle and from angle to radian. We'll see this one. Students, what is the value of pi actually?
3.40. No, in radians.
What is the value of pi? 3.14. That's it. Yeah. What you know, it must be like this. 3.14. Now we are going to learn in trigonometry. What is the value of in trigonometry? 180 degrees. If you are using pi in angle measurement, in this case you must understand pi here, 180 degrees. Okay, let's see to this side, I think. Pi is 180 degrees, pi or 3.14. Both are used. For example, if you remember when we talked about the sectors and segments, we wrote the formula of finding length of sector. And in that formula, length of sector, but anyway there is pi. In that formula, pi is 3.14. But when we are writing angles like pi over 2, pi over 3, in this case, actually pi must be 180. Okay, formula from angle to radian. But what is radian? Let's see first this one. What is radian? What is radian? Do you have any idea about this conception? Any?
It was measurement of angles? Or?
It's also measurement of angle, the second type of measuring angles. But
With
isn't it like this? Like if it's 90 degrees, it's like pi over 2. If it's 90 degrees.
100, yeah, like this. But radian actually, 1 radian is 180 over pi. 1 radian is 180 over pi. But pi here is not 180. Pi is here 3.14. Yeah, 3.14 actually it is when we put the answer will be 57.1 or 57.3, such kind of angle you'll get. In this case, 1 radian, it's 57.3 degrees. It's not exactly, it's almost this angle, okay? Not exactly, almost 57.3 degrees. So this is 1 radian. In this case, when we are from angle to radian, converting the angles, in this case we must multiply angle to this measure. For example, let's say 300, 300 degrees if you have. From angle to radian, it must be actually vice versa, not 180 pi. Pi over 100 it must be. Let's say pi over 180. This is alpha. Now it's in radian. Pi over 180 multiplied by alpha. Yeah? It's from angle to radian.
Alpha is an angle,
Yes. From radian to angle now. And in this case, alpha, we must find alpha. 180 over pi multiplied by radian. So that's it. Let's see, for example, pi over 2. You know, pi actually in such cases, it's 180, yeah? If you put instead of pi 180, what is the measure of this?
90.
It's 90 degrees. It's 90 degrees. And pi over 3.
60.
It's 60. Yeah? You are finding this instead of pi putting 180. But what about to radian from angle? Let's say 110. Yeah? Alpha is 110. And we must find in radian. Yeah? In this case, the radian, we're going to use this formula. Radian equals pi over 180 multiplied 110. Yeah? We can actually reduce or cancel out 10 because they are divisible by 10. 11 pi over 18. That's it.
Okay.
Question? That's it. Question?
No.
So, students, if you have any question, you may ask. I couldn't catch you, mister, what you said actually. You'll have time to write all things, don't worry. You'll have time at home. So now it's time to start actually writing formulae. In trigonometry, a bunch of formulae.
If I'm not
Like
mistaken,
basic
there is
formula.
about 90 formulas.
You cannot count how many formulae actually are existent in trigonometry. You cannot count. Because if you remember, make the subject in the formula, changing one variable to the next one. You can change and you may have new formula, new formula, new formula. You cannot
Like,
count.
and corollary your actions.
Corollary actually, coming from the first idea, you can say the another idea. But
Coming from the one.
it's not called corollary because it's not theorem. Theorem actually is changed to the another theorem. In this case, it's corollary. But in algebra, if you change one formula to the another one, in this case, it's called just rewriting formula or
Making
rearranging formula. If you remember, rearranging formula, it's called. Yes, Sivara? Is it true? What is the rearranging the formula? You think it's corollary. Okay. But what about rewriting formula?
making subjects another part of
Yeah.
equation.
Changing the subject in the formula, that's it. That's it. So now I'm going to write formulae, a bunch of formulae.
Okay.
So, first of all, I'm going to say name. It's called main trigonometric identities. What was identity? What's that? What is the definition? I don't need translation.
Two sides are
When the
equal.
answer can be all real numbers.
And the first part equals to the second.
When the two parts are equal, for example, sine is
You must show whether they are equal or not. You must show. Perhaps they're not equal. Okay? You don't know it's equal or not. When you proved, when you show, when you indicate they are equal, then you can say this is identity. Now they are identical. Identical means the same. They are the same. You can say like this. But first you must prove this. You cannot say just, okay, both sides are correct, both sides are equal, that's why they're identities. No. First you must show. With words you cannot say, you must show. So what is the symbol of identity? Who can say symbol?
Three
Three
dishes.
dishes.
Yeah, three, this kind of, yeah?
Yes.
Three. It's symbol of identity. And I want to say actually about why I said perhaps the identities or formulae are so many in trigonometry. The reason I said like this because there are so many identities. Any identity can be formula, if you remember. But any identity, when it's proven, then it will be formula. But you can take any formula and you can say this formula is identity or equation. Any formula can be equation or identity. But when you are saying identity can be formula or not, first you must show, as I said earlier.
Perfect.
Then it will be formula too. But identities are infinite. Identities are infinite. You can create new identity by using some terms and elements. That's why it's infinite. Okay? And we cannot count because of this reason. How many formulae are existent? So let's start. First one. I guess you know this one. Sine square alpha plus cosine square alpha equals 1. You know this. And you may do some kind of derivations. What is derivation?
Changing the subject.
Create new formula. Yeah, changing the places and create new.
Finding the sine alpha
One
equals
minus
cosine alpha.
Sine alpha actually, it's thinkable. Yeah? You say like this? Thinkable? What does it mean?
Mem.
Okay, but how do we know it's positive or negative?
Planes, the planes that you showed earlier. The plane
Yeah.
in which
Okay, we know actually science in the planes, but how to find this? We must look at what? Specifically, we must look at degree. We must look at angle. If there is angle which is greater than 90, for example, for cosine, in the second plane for cosine, it's negative. It doesn't matter sine is positive. You don't think so that if sine is positive, cosine also positive. No, because sines are different. If sine is positive, perhaps cosine can be negative. You must check this. It's the first one. And the second one, tan alpha sine over cosine. And third one,
1 plus
cotan cosine over sine alpha. And the fourth one,
1 plus tangent
tan alpha cot alpha, it's 1. And the 1 plus tan square alpha, 1 over cosine square alpha. And 1 plus cotan square alpha, 1 over sine square alpha. You can create new identities from here too. Just changing the places of sine and cosine. Okay? I think for now it's enough. There are many, but main trigonometric identities, they are 6. That's it. Okay? Adding points. Adding angles in sines and cosines, or a formulae of addition. Okay, these are also new formulae. I must say this one. So, but formulae of reduction will be the next time. Formulae of reduction will be next time. Today, the last part of today's lesson actually in the explanation part, only to see formulae of addition. Formulae of addition, like alpha plus beta, alpha minus beta. Who can tell me actually why subtraction also can be addition? What's the reason?
Cosine may be negative and minus.
No.
like sinus alpha plus.
For example, a minus b, a plus b. We call both algebraic addition.
Because
What's the reason to say algebraic addition? Both are algebraic addition. What's the reason to say that?
minus b.
Yeah, b here, negative number. There is no subtraction in algebra. There is no subtraction. We say algebraic addition. That's why formulae are also called formulae of addition, even though they are sometimes consisting of subtraction. Okay? So that's it. So let's start in this case. Formulae of addition. The first formula, sine alpha plus beta.
Cosine is alpha.
Sine alpha cosine beta.
Plus cosine is alpha.
Cosine alpha sine beta. Sine alpha minus beta. It's the same, but yeah, it must be minus.
Cosine is alpha.
Now cosine alpha plus beta.
It's cosine is alpha. Cosine is alpha. Cosine
Minus.
minus.
And negative one,
Between
the same but positive. Third one, tangent alpha plus beta. Tan alpha plus tan beta over 1 minus tan alpha tan beta. That's it. And tan alpha minus beta, actually just signs are different.
Cotangent is the vice versa of tangent.
Yeah, you may put instead of tangent 1 over cotan alpha, 1 over cotan beta, 1 over cotan alpha, 1 over cotan beta. Then you will find cotan alpha plus beta. That's it. Okay? Yeah, in your book also it was given like this. I mean, instead of they wrote like this, tan alpha, tan beta. They put just 1 over. That's it. So it's just the last part of today's lesson's explanation. Now we'll start questions. Question number 1.
On which page?
On page 54. A. 45. Express in radians the angles. We have 45 and we must express in radian. We have formula. Radian equals pi over 180 alpha. Alpha is 45. Instead of alpha, we're going to put 45.
Pi over 4.
If we reduce, pi over 4. That's it. Did you understand the first question?
Here said that express in radian. It means from angle to radian or from radian to angle?
Express in radians.
Like from angle to radian.
Where is it in radians? That's it.
It means from angle to radian.
Yes.
Это
So-
расстояние?
Это почти.
We just-
Только разные.
Мы выражаем угол через пи.
Не, это вообще что? Радиан это вообще что? Радиан это просто другое измерение угла. That's it.
Просто по-другому изменяется.
Yeah.
А зачем они нужны?
Это кто-то придумал.
Чтобы легче было. В будущем увидеть.
Tried angles. Yeah, tried angles you need. That's it. For now, tried angles you need. Two right angles you need. That's it.
And here you saying the angle with degree 45, it is P over 4?
Pi over 4. We wrote 45.
The angle
Yes.
is pi over.
I'm saying this angle. Tried angles we need. That's it. Question number 2. Pi over 3. We said pi actually 180, yeah? 180 over 3, it's gonna be 60. But if you want to solve this, you must use formula. Alpha 180 over pi radian, yeah? And 180 over pi radian here, pi over 3. 60. That's it. You must show like this in exam. Okay? Write first formula, then show the solution in exam. So question number 3. Okay. Now we'll check your preparation for the lesson. Your home assignment was to learn degrees and values of sine, cosine. If you remember, students. Now we'll check. So what is the value of sine 0? We did this in the beginning of lesson as well. It's 0. And what is the value of cosine pi over 2? 0. What is the sine pi over 2? 1 square, it's 1. And what is the value of sine pi over 6?
1 over 2.
1 over 2. 6 times 1 over 2. What is the value of cosine 0? 1. What is the value of tan pi over 3?
Square root of 3.
Square root of 3, but there is square. Square root of 3 and there is square. I'll say 3. Yeah? 0, 0, it's 0. If you just reduce this 3, 3 minus 2, 1 plus 3, it's 4. That's it.
No, I think it's 5. No. Like 1 plus 3 before.
There is 1. It's 5. It's 5. Thanks. So, question number 4. Cosine alpha, it's 1/3. Alpha between 0 and 90. What kind of angle is this?
It's positive.
What kind of angle is this? Name of angle, type of angle. Acute. This is acute angle. And find the values of the rest trigonometric functions. Hint, use the main trigonometric identities. Of course we use. Okay.
And it's like
It's actually which plane? First plane, yeah? So, we must find the other trigonometric functions. Sine, tangent, cotangent. To find sine, 1 minus cosine square alpha on the square root. But in the first, it's positive. We don't need to put any sign. If the value of this 1/3, it's gonna be 1/9, and answers like this. Yeah? It's sine. To find tangent actually sine alpha over cosine alpha. If sine alpha is like this and cosine alpha like this, in this case tangent is this one. Yeah? And cotangent alpha actually 1/tan alpha. Yeah?
1 over
And
square root
1
of
over
8.
square root of 8. That's it. We found. That's it. So now question number 5. Question number 5. Find the values of following using the formula of addition. Okay, A, sine 30 plus 30, yeah? Okay, it's easy, but anyway, we're gonna find, okay? So, sine 30, cosine 30, plus cosine 30, sine 30, yeah? Sine 30, it's 1/2. Cosine 30 is square root of, yeah, this one. And again, this one, and 1/2. They are the same. Yeah? In this case, 2 square root of 3, 4. Square root of 3 over 2.
Or we can say sine of 60 degrees. It's
Yeah, it was possible. But what about D1?
could we just add the
Yes.
degree?
No.
nothing, just it. We cannot. Just nice.
No.
It's like 60 plus 45.
60 plus 45.
Yes, of course. You're right, students. And tan 60 plus tan square root, tan 45 degrees. 1 minus tan 60 tan 45. Yeah? And tan 60 square root of 3. Tan 45 1. Square root of 3 and 1. That's it. It's the value of tan 105. Sevinch, I don't know when you asked this question, but you asked how to find the other degrees. Yeah? 105. Now we found. It's not in table. She doesn't remember, but anyway.
No, I remember that I asked, but how
Okay.
to
Firdaus said that we
Yes,
cannot
yes,
find
yes.
the 100 degrees.
With functions, with просто.
With formula we found. With formula. For example, we know value of 60 and 45. We know the value of 60 and 45 for tangent. And 105, actually 60 plus 45. In this case, it's alpha plus beta. Tangent alpha plus beta. We know the formula. Tangent alpha plus beta. tan alpha plus tan beta. 1 minus tan alpha tan beta. This is formula. And 105 actually 60 plus 45. If you add 60 plus 45, that's why we can use this one. It's the same thing. And when you put instead of alpha for 60 instead of b 45, you're going to get this one. And you know the value of tan 60. It's 3 square root of 3. It's 1 plus 1 minus this one. That's the value of 105 for tangent.
Or in the
So the next question. Question number 6. Okay.
Sine 750, we should divide by
No, it's like
360 we're going to divide, yes. 150 we're going to divide this to
1080 minus 30.
or like this, you're right. 1080 minus 30, yeah? Why you said like this? What's the reason? Because 1080 is divisible by 360. You must find which the first number must be divisible by 360. If you remember 360, it's beginning or end point in the unit circle. In this case, the same value always. It doesn't matter. Actually, 2 pi, actually 360, yeah? 2 pi k. 2 pi k means instead of k you may put any number. If you put anyway, the result of sine cosine doesn't change.
zero. It depends on cosine or sine.
Wait, what is the value of cosine 90? 0. Cosine 90 always 0. It's if it's negative or positive, it doesn't matter. It's 0. Cotan 660. Yeah, it's like this. Cotan
720 minus
60, and this one 360 plus 45. This one 360
minus 45.
minus 45. Yeah, bingo.
Yes, bingo.
Okay. Sine.
Sine 1 over 2, yes. Because when we divide,
Let's draw unit circle.
Minus. The fourth plane will be and it will be negative.
Okay. 30 degrees. Let's say if it's 90 degrees, 30 almost here, yeah? And value of 30 it was 1 over 2, yeah? And if you put such kind of line, yeah? Because vertical always y, yeah? Vertical asymptote, if you remember, it's y. Horizontal asymptote, it's x, yeah? No, sorry. Vertical line here just y. This only y, but here it's x. Sorry, it's x. Vertical asymptote, it's x. Horizontal asymptote actually was y. But it's only necessary. It's only necessary for finding the value. Here it's a little bit different, students. If it's 30, y is 1 over 2. If it's 30, it's going to be the same value, but
with minus.
minus. Yeah? Minus 1 over 2. And cotan 720 minus 60. Actually, 2 pi k. Like 720, 1080, they are divisible by 360. It means at this point the values are the same, always. Always, because this is 0 and 360. Okay.
No,
Yeah. it's gonna be 1 over.
No, it's
No, square root of 3.
What is the? First of all, let's find sine. What is the sine here in the first plane for cotan? Negative.
Minus.
1 over square root of 3. And plus 360 this angle plus 45. 45 plus, yeah, here, yeah, 360 this point and 45 this point. Cosine 45, you know the value of cosine 45?
It's equal to sine 45.
Not from the root, square root of 2, square root of 2 over 2. Fazilat, I paid attention, you've said like this 4 times or 5 times from the root of this. No, square root, okay? So this one now, 360, yeah, minus 45. By the way, plus 45, it's anti-clockwise or counterclockwise. And minus 45, it's clockwise, okay? So 360 minus 45, it's clockwise. We are finding for sine. Sine in the first plane it's negative. 45,
Minus,
but negative.
square root of 2 over 2.
we can just eliminate.
They are opposite numbers. The sum of opposite numbers is 0. And that's why they're 0. And left only this part. Common denominator. Yeah? That's it. Or if you rationalize this one, it's going to be 6, yeah?
Yes.
And we're going to multiply this to both. That's it. Rationalizing is needed, Firdaus, okay? When you're writing.
Don't you use the big
Me?
degrees there?
We can in tangent too.
1080.
Sorry.
Why don't you use the big degrees in
It's
sine
the same.
cosine? 1080, 720.
Look. If you put any, let's say 30, yeah? It starts from here, 30 degrees here. That's it. But we are finding for 1050, yeah? It means it's less than 1000 for 80, yeah? 1080. But why 1080? Because 360 it's divisible for this number. Why divisible? We need because one complete turn is 360. If you start from this point anyway, you're gonna come here after 360 again here. Again you are here after 360. It's 360 degrees, but you are here. What about the next 360? Now it's going to be 720. But anyway, you are here. You are just like revolving. Okay? Do you understand revolving? What does
Yes.
it?
Make circles.
1080.
Revolving. Turning.
Around, like going around.
Turning around.
180 degree is how many revolvings there?
3 times. It's 3 times full revolving, but one angle is needed here. It's not enough. Yeah, it's less than this one, 1050. Yeah,
Then you should
it's gonna stop here. Not full. The third one is not full. It's gonna stop here.
you should just reduce 30 degrees, yes?
Yeah, because this necessary angle is 30. We need 30. And what's the value of sine 30? It's 1 over 2. But in the first plane, sine of sine is negative. That's why it's going to be minus 1 over 2.
Okay.
Understood?
Yes.
So, question number 7, it's going to be last question of today's lesson. Then we'll finish, okay? Question number 7. So you may find this by multiplying to this side and to this side, up to this part. We're going to separate this question into two parts. We are separating this question into two parts. Sevinch?
Yes. My mom called me. I said that.
We are separating two parts. This is just sum of the square, square of the sum, square of difference, yeah? But here we're going to multiply this common denominator to 1 and to sine. By the way, students, alpha can be the alphabet. Okay, any letter can be instead of alpha. A, B, C, D, E, F, G, X, Y, Z, okay? So 1 plus sine x, if you multiply, minus cosine square x, minus sine x, minus sine square x, yeah? So 1 plus sine x, this is the first part of this question. So sine x and sine x, they are opposite. The sum of them is 0. And minus and minus.
Okay.
If we put this minus outside, positive?
Yeah.
And the sum of them is 1. But there is minus. 1 minus 1?
0.
First part is 0. And the second part, so we are going to open this one. 25 sine square y plus 40 sine y cosine y plus 16 cosine square y plus 16 sine square y minus 40 sine y cosine y plus 25 cosine square y. Look, this is positive, this is negative. Sum of them is?
They will be reduced.
0.
0. And 25 sine square plus 25 cosine square. Let's put 25 the outside, yeah?
Yes, and 1.
And plus here 16, yeah? And sum of them is 1, 1. 25 times 1, 41. So that's the end of today's lesson, students. The other questions are home assignment. Thanks for coming. Goodbye.